Concentration terms look like simple definitions, but understanding their theory properly is what separates toppers from average students. In today's video, we are going to discuss all concentration terms without any confusion. After completion of this 30 minutes video, you will be comfortable in all these concentration terms. So before entering into concentration terms, first let us take the term solution. We know solution, that is homogeneous mixture of solute plus solvent. Solution is homogeneous mixture of solute plus solvent. So how we define solute as well as solvent here? See, the general definition, solute is referred as minor component in a given homogeneous mixture. General definition. Solvent referred as major component. Solute as well as solvent, main difference. For example, if I consider a solid as well as liquid, if I take a solid as well as liquid, which gives solution whose physical state is in liquid state. Whenever we take a solid and liquid, solid is here solute. By default here liquid is solvent, because the physical state of solvent as well as solution always same. The physical state of solution is liquid state, that is here liquid is solvent, solution solvent physical states always same. For example, if I take both are liquids, if both are liquids, in such cases again you will get solution as liquid form. If both are liquids, in such cases the one with higher moles is solvent. For example, here I am taking 1 mole of H2O. Let us assume it. Another liquid is 9 moles of ethanol. 1 mole of H2O, 9 moles of ethanol. Both are liquids. Physical states of both the components liquid state. In such cases, the one with higher number of moles we refer it as solvent. The one with lower moles we refer it as solute. And the overall, if you see, generally major component is solvent. Both are liquids. Major component in terms of moles you have to calculate, not in terms of mass. One is liquid, one is solid. Automatically liquid is solvent. That is main difference between solute as well as solvent. Now, the first concentration term, that is mole fraction. Mole fraction, which is represented by letter X, mole fraction. For example, here I am taking a beaker with two components A and B. Beaker with two components A and B. If you want to find mole fraction of A, here we calculate number of moles of A by total moles in the beaker. Total moles in the beaker, like number of moles of A plus number of moles of B. Similarly, if you want to find number of moles of B or mole fraction of B, number of moles of B by number of moles of A plus B. So overall what we are doing here, number of moles of particular component by total moles, which is equal to mole fraction of respective component. Remember, if solution contains here two components, sum of these two mole fractions always equal to 1. Sum of those two components in a given solution, mole fraction sum always equal to 1. If three components, sum of those three mole fractions equal to 1. Important statement, sum of mole fractions equal to 1. One hack point here, mostly they test in terms of these sentences. See here, ratio of mole fractions. Ratio of mole fractions. Whether mole fractions given in the question or you can write here ratio of moles. Ratio of mole fractions of given components is equal to ratio of moles. You can take it as hack point. JEE many times mentioned as a statement or question based on this given statement. See, in this video purely we are going to focus on theoretical concepts. Format you see, lecture 1 theoretical concepts, lecture 2 questions, lecture 3 theoretical concepts, lecture 4 followed by questions. Follow same format throughout the series. Next concentration term, that is percentage weight by weight. Percentage weight by weight. So percentage weight by weight, how we define? Percentage weight by weight is equal to weight of solute we specify in grams by weight of solution in grams into 100. In grams into 100. Here there is confusion point. Most students make silly mistakes and lose marks in JEE Mains because of confusion in percentage weight by weight. How we need to interpret here? See. For example, I am taking here 40% weight by weight NaOH. 40% weight by weight NaOH, meaning how we need to interpret it? The 40% weight by weight NaOH meaning 40 grams of NaOH, 40 grams of NaOH present in 100 grams of solution. 40 grams of NaOH present in 100 grams of solution. Or you can refer, or you can analyze statement as 40 grams of NaOH present in 60 grams of solvent. Anyway you can analyze based on given question, you can analyze in any way. Percentage weight by weight. Next term, percentage weight by volume. Percentage weight by volume, similar here, weight of solute in grams by volume of solution in ml into 100. So percentage we specify here. So how we need to observe it? See here. Observation point of view, how we need to consider? See. If there is 20% W by V NaOH solution, if it is given, so how we need to observe it? Means here see, the given information means 20 grams of NaOH present in 100 ml solution. 20 grams of NaOH present in 100 ml solution. That's how we need to consider. Like above, you cannot even 20 grams of NaOH present in 80 ml solvent. Anyway, you can consider here 20 grams of NaOH present in 100 ml solution. W by V. Next, percentage V by V. See, V stands for your volume. So here we specify volume of solute in ml by volume of solution. Volume of solution in ml into 100. Volume of solution in ml into 100. So here, how we need to consider? See, overall, what is the meaning here? See, for example, if it is 20% acetic acid, 20%, that is V by V percentage, if it is given. So meaning 20 ml 20 ml acetic acid in 100 ml solution. 100 ml solution, percentage V by V. 100 ml solution. Next, observe all those till now. Next, moving further, molarity, which is represented by capital M. Do you know exact difference between molarity and molality? If no, if there is confusion, properly pay attention and listen. Molarity, represented by capital M. So how we define molarity? Molarity is equal to capital M, number of moles of solute, small n representing number of moles, and volume of solution in liters. Number of moles of solute by volume of solution in liters. And here units of molarity. See, observe it here based on given formula. What are the units of molarity? Units of molarity. So here we write mole per liter, or capital M, or you write molar. All are same. Mole per liter or capital M or molar, units of molarity. Further, you can modify this expression. How? Let us see. How we can modify? See here. For example, in this case, molarity is equal to number of moles. How we can write? Given mass by molar mass or molecular weight by volume of solution in liters. Further, you can write even weight by molecular weight. If I take volume of solution in ml, then here 1000 we mention. Another formula, molecular weight into volume of solution in ml, 1000 above. That is molarity related formula. Here one important conversion you need to remember. Important conversion here. See the conversion which is useful everywhere. 1 ml is equal to 1 cubic centimeter, which is equal to 1 cc. 1 liter is equal to 1 cubic decimeter. 1 liter is equal to 1 cubic decimeter. 1 ml is equal to 1 cubic centimeter or 1 cc. These are important conversions. Next, moving further, even there is one more related formula. You can specify even molarity like this. Molarity also written as in terms of percentage by mass of solute. Just now we discussed about weight by weight, percentage mass of solute into 10 into density of solution, 10 into density of solution by gram molecular mass of solute. Gram molecular mass of solute. So important point, you need to remember the overall relation. Molarity is equal to percentage by mass of solute into 10 into density of solution by gram molecular mass of solute. So important formula, one more we are going to use in upcoming lecture for the calculation purpose. Next, molality. Molality here how we consider? There capital M, here small m. Capital M, here small m. So here under molality definition you see here, small m is equal to number of moles of solute. Here no difference, but see the denominator here, It is mass of solvent. It is mass of solvent in kg. Which mass? Given mass, not molecular mass. Or if any doubt, you write here weight of solvent. Weight of solvent in kg. Further, if you modify like molality, I am writing here weight by molecular weight into weight of solvent in kg. The most important where students make mistake, this part. I am highlighting it. They write solution, but here remember it is solvent. Here also you see, here it is solvent. Coming to units. Units of molality, see the difference here. There we wrote volume of solution. Here weight of solvent. So units of molality, mole per kg you can write, or small m, or you can write molal. So both are, all are correct. Anyway you can specify. So you can mention in any particular way to get answered. See here. Units of molality, either mole per kg or small m, or you can write it as molal for molarity representation. Next, further if we move, there is interconversion formula. There is interconversion formula. Whenever mole, here advanced questions, pay attention everyone students. Here there is interconversion relation. Do you know interconversion between molarity and molality? Which plays most significant part in advanced questions? Once you recollect interconversion formulas, whatever you remembered, interconversion related formulas. See here. First formula, I am writing here, molality is equal to, you have to remember, next lecture we are going to use all these to calculate. Molality is equal to mole fraction of solute by mole fraction of solvent into 1000 by mole fraction of, molar weight of or molecular weight of solvent. So pay attention, very good important interconversion formula, useful for advanced questions even. Next interconversion formula, that is molality is equal to, molality is equal to 1000 into molarity, 1000 into molarity, remember it is molarity. So 1000 into molarity by 1000 into density of solution, 1000 into density of solution minus molarity into molar mass of solute, or you can say molecular weight of solute. So here important formula. These interconversion formulas makes difference, show the difference between top students as well as slow learners. Molecular weight of solute. So keep it in box. See here. Properly observe once again. I am showing here box for this interconversion formula. Molality is equal to mole fraction of solute by solvent and 1000 by molecular weight of solvent. Molality is equal to 1000 into molarity by 1000 into density solution minus molarity into molecular weight of solvent. Here you can mention even a bracket so that no confusion in calculations. Okay, next concentration term, that is next concentration term after completion of molarity, next moving to ppm. You can say ppm. So what is ppm here? It is nothing but parts per million. Parts per million. So how we calculate ppm here? In two ways you can specify ppm. So here number of ppm by mass is equal to weight of solute in grams by weight of solution. See, ppm we use only for very dilute solutions. Into parts per million it is, so 1 million we are using. Remember, it is by mass. In terms of mass we expressed. Same if you want to write for volume. Number of ppm by volume is equal to volume of solute, which we mentioned in case of ml, by volume of solution also in ml into parts per million. So here it is 10 power 6. There parts per million by mass, here by volume. Otherwise overall formula related. Both are related. Next, strength. Sometimes they specify strength of solution. Strength of solution, how we calculate? See, strength of solution especially we mention for gram per liter. So here whenever they ask for strength, you express answer in gram per liter. Their weight of solution in gram by volume of solution in liters. See, normality term, there is one more term, normality. So normality term will be discussed in redox reactions topic, not here. Remember last one relation, when two solutions of same solute mixed, when two solutions of same solute are mixed, two solutions of same solute are mixed, then how we find? When two solutions of same solute are mixed, same type of solute, then to find new molarity, then what we use? New molarity, or you can specify like total molarity, volume total is equal to m1 v1 plus m2 v2. Here there is formula. Here it is for solution 1. Think that it is for solution 1. It is for solution 2. Of same solute, if we mix the resultant solution, molarity, volume, we calculate by using this formula. And the last step, case 2. If solution is diluted, then to find new molarity of the solution, then we find here m1 v1 is equal to m2 v2. See, m1 is initial molarity of the solution, v1 is initial volume of the solution. We use before dilution, after dilution. See here m1 v1 before dilution, m2 v2 after dilution, m2 v2 after dilution. So these are most important concentration terms or interconversion terms, whatever we discussed till now. In this video, overall we discussed about theoretical concepts. But the most important thing here, applications of all these terms will be discussed in upcoming video. Stay tuned to ChemHack Point. Thank you for your patient listening.